Welcome back everyone, Houston Math Prep here with a non-homogeneous example using reduction of order on second order equations. So here we've got the equation y double prime minus 5y prime plus 6y equals e to the negative x. And a known solution that we're given is y1 equal to e to the 3x. So remember, with reduction of order, the idea is that our general solution for this equation will equal some u, some function of x, times the y1 that we are already given or already know. So in this case, if my y1 is e to the 3x, then y is going to equal u e to the 3x. So we'll have a substitution for this 6y term here. We'll need y prime and y double prime to fill in over here. So y prime as a product rule here, this is a function of x times another function of x. We'll get u prime e to the 3x plus the derivative of the other now, so we'll say 3u e to the 3x, so that's our product rule there, gives us y prime, so we'll have something for that. Now we'll need to take the derivative of this again to get our y double prime. Now remember, each of these are going to be a product rule, right? So a few more steps here. So derivative of this first piece, so we'll get u double prime times e to the 3x. Plus, now the other half of our product rule here would be 3u prime e to the 3x. So that's this piece. Let's do the other piece now. Plus, the derivative of the first part would give us 3u prime e to the 3x. And the derivative of the e to the 3x part now, second half of our product rule, another 3 would come out, so we get 9u e to the 3x. Let's go ahead and combine these like terms in the center. So we'll say u double prime e to the 3x plus we actually get 6u prime e to the 3x if we combine this term and this term, plus 9u e to the 3x. Okay, so we have everything that we need to plug in for the left side. The right side will just stay as it is. We'll go ahead and plug everything in. So our y double prime is u double prime e to the 3x plus 6u prime e to the 3x plus 9u e to the 3x minus 5y prime is the next thing in our equation. So we'll plug in y prime, which is u prime e to the 3x plus 3u e to the 3x plus 6y, so plus 6, plug in your original u e to the 3x, is equal to, now we have e to the negative x, non-zero on the right-hand side, because this is a non-homogeneous example, right? Okay, let's do some simplifying here. So we'll have u double prime e to the 3x, we'll keep all this stuff here, plus 6u prime e to the 3x, plus 9u e to the 3x. Distributing the negative 5, we'll get negative 5u prime e to the 3x minus 15u e to the 3x plus 6u e to the 3x is equal to e to the negative x. Now remember, if we've done this correctly, our u terms should vanish, should add up to 0. So notice we have a u term here, 9u times the exponential. We have another 6 there, so 9 plus 6 would give us 15. We've got minus 15 here. So all of those add up to 0, which is nice. And let's go ahead and combine these like terms over here, the u prime terms. So we get u double prime e to the 3x. 6 minus 5 would just be plus 1u prime e to the 3x equals our right-hand side, right, equals e to the negative x. And for a non-homogeneous problem using reduction of order, when we do our substitution, so remember we let v equal u prime, and that's going to reduce the order, thus the name, to a first order equation. That's going to actually give us, because it's non-homogeneous, remember that's going to give us a linear equation, and we'll have to use an integrating factor to do this. If v is u prime, obviously that means v prime is going to be u double prime, right? So let's go ahead and plug in all that stuff over here. That would become v prime e to the 3x plus v e to the 3x equals e to the negative x. Go ahead and give ourselves some more room. And so now think about, this is really like dv dx e to the 3x plus v e to the 3x equals e to the negative x if you prefer to see it this way. This is not in the normal form though. Remember, for a linear first order equation, the normal form, we just want dv dx. We don't want this term here. We actually need to divide everything by e to the 3x. First, if we go ahead and do that, we'll get dv dx plus v is equal to, just be careful here, we get e to the negative 4x. Now this linear equation is in its normal form, so we can go ahead and find the integrating factor. The integrating factor, remember, is e to the integral of whatever function is in front of v here. It's actually just a 1v, right? So the integral of 1 dx. That's just going to be x, right, when we integrate. So we get e to the x. We'll multiply everything in the equation, remember, by the integrating factor. That's what our integrating factor does. So we'll get e to the x times this dv dx plus v on the left-hand side. On the right-hand side, if I multiply this by that, we'll get e to the negative 3x. And now if you remember first order linear, this is actually a product rule of v times your integrating factor. So when we take the antiderivative of this, don't overthink it, this is just v times e to the x. Here we'll actually do the integral, so the antiderivative of e to the negative 3x with respect to x. We'll get v e to the x is then equal, reciprocal of negative 3 will come out, so I should get negative 1/3 e to the negative 3x plus some constant. And then to solve for v, we'll have to divide by e to the x, right? So we'll get v is equal to negative 1/3 e to the negative 4x, if we divide by another e to the x, plus c1 e to the negative x. So that's our v, and remember v was u prime, so u prime equals all of this, right? But now what we actually want, remember our solution is going to be y equals u times y1, so we need to take the antiderivative of this. So u is going to equal the antiderivative of this negative 1/3 e to the negative 4x plus c1 e to the negative x. So if we take the antiderivative, then u is going to equal, we'll have a negative 1/4 coming out front. We already have a negative 1/3, so that'll be 1/12 e to the negative 4x. And now for this next term, when we take the antiderivative, a negative 1 would technically come out, but c1 is just some arbitrary number. It could be positive, negative 0, so the negative 1 doesn't really matter. We just get still plus c1 e to the negative x there. We would get plus c2, though, from integrating this time. And so now we know our solution is going to be u times y1. So this times our original y1. So y is going to equal all this stuff, 1/12 e to the negative 4x plus c1 e to the negative x plus c2. And remember, if we scroll back up, our original y1 was e to the 3x, right? So we're going to multiply this u that we got times e to the 3x. So we're going to get here then, if we multiply by e to the 3x, we'll get 1/12 e to the negative x for this first term. E to the 3x, remember you're adding exponents, so this actually becomes c1 e to the 2x, and this one becomes c2 e to the 3x. All right, everyone, hopefully this non-homogeneous example has helped you out. Good luck on your reduction of order. Thanks for watching. We'll see you in the next video.